Maximum power transfer. Consider you have a circuit, okay, and it contains it's composed of linear components such as resistors, sources, but linear sources, okay, linear components. You connect a load to that circuit, okay, between points A and B. What should be the situation for the maximum power transfer? To calculate this, okay, what should be the value? Okay, value of RL for maximum power transfer. To calculate this, first you have to calculate the Thevenin equivalent of that circuit. Okay, this is the Thevenin equivalent of the circuit, large circuit. First, you you exclude RL, okay, you reject it, calculate the Thevenin equivalent of points A and B, and then insert RL again. Now, insert RL. What should be the situation for the maximum power transfer? Okay, V Thevenin is a fixed value. That's Thevenin voltage of the circuit. R Thevenin is a fixed value. It's the resistance of the circuit. Consider like that. What should be the value of RL? Okay, to get maximum power, to absorb maximum power from the circuits. That situation is RL is equal to R Thevenin. Okay. Actually, the power of RL is I squared RL. Okay. And if you draw the graphic of that equation, it will be something like that. This is the value of RL. Okay, actually it goes to infinity. Then RL is 0. RL is 0. Okay, then I square RL will be 0. Okay, if it goes to 0, if you make it very small, it will be 0 because of this multiplication. And if you use a very large RL, if it goes to infinity, then I is equal to Thevenin voltage is a fixed value divided by RL. Okay, if RL goes to infinity, I goes to 0, so I squared RL goes to 0 again. Okay, and if RL is equal to R Thevenin, then I squared RL is the maximum. Okay, and if they are equal, it means half of the power, okay, total power is the power dissipated by the internal resistance, Thevenin resistance, and the load, and they are equal. Okay. So half of the power is dissipated in the circuit, and the other half is transferred to the load resistance. Okay, and the maximum value of the power generated by a circuit is the half of the power. Let's have an example. Let me say RL. Okay. Question. What can be the maximum power dissipation on RL? First, we have to calculate the Thevenin equivalent of the circuit. Points A and B. Okay, this is the circuit. I have to calculate the Thevenin equivalent of the circuit. So, what's the voltage? There is a voltage division. 10 volts is divided on 2 resistors. 5 divided by the total, which is equal to 3.3 volts. Okay, which is the Thevenin voltage. And what's the Thevenin? What's the Thevenin resistance? Yes, this is my circuit. While calculating the Thevenin resistance, I have to turn the sources off. Turn this source off. This is a voltage source. If you make it off, if you turn it off, it will be short. So 10 and 5 ohms are in parallel. Okay, so 10 parallel with 5, which is equal to 50 divided by 15, which is equal to, which is 3.33. Oh, fortunately they are the same. Okay, so I have calculated the Thevenin equivalent. This is 3.33. This is the same. Okay, that's chance. And then I will connect RL, and I know that RL should be equal to the Thevenin resistance of the circuit. I have calculated that's 3.33 ohms. Okay, so in that circuit, if I connect 3.3 ohms, RL will be dissipating the maximum power. So if I connect that voltage, that resistance, that value, what's the power? Power is I squared RL. What's the current? What's the current of the circuit? Voltage divided by the resistance. Voltage is 3.33. Total resistance is the twice of that. I squared. That's I, current. Okay, voltage divided by resistance times the resistance. 333. So which is equal to 1 over 2 squared 3.33, which is 3.33 divided by 4 watts. Okay.